Hi everybody, welcome to another video in Trigonometry, section 1.4, reference angle. From the previous section, we defined trigonometric function. These are 6 of them, and some special values. We can use this trick to find trigonometric function values. Now we extend this to a lot more values of trigonometric function. Right, reference angle. The reference angle is a positive acute angle theta. If we have original angle is theta, then theta prime is called the reference angle. We denote by theta prime, formed by the terminal sine of theta and the x-axis. So the standard angle, a standard position angle in standard position, the initial ray is the positive x-axis, as in here reference. It could be positive or negative x-axis. So it could be so it could be positive or negative x-axis, whatever produce an acute angle. So that's definition. So let's take a look at some example. Let's say if this is the angle theta, the reference angle is the angle that make with either positive and negative, whatever produce the acute angle. So the acute angle is going to be here as well. So that is theta prime. So in this case, if it is in quadrant 1, theta prime is equal to theta. And that with a little. Of course, if we go around a few revolutions, that will not work. So let's say the reference angle in each quadrant, assume that the angle between 0 and 360 degrees. We're not talking about more going around. We're not talking about coterminal angles. Of course, if we have an angle that goes around and around like this, that of course different situation. Now we prefer everything less than 1 revolution. All right. So with that, reference angle in quadrant 1 is the same. Now reference angle in quadrant 2. Now if we have an angle here, that is an angle. Our reference angle is the angle where we form with either positive or negative angle, whichever produce a positive acute angle. So this is that reference angle. We make using the terminal ray and a negative x-axis in this case, because if we use the positive x-axis, it will produce an angle that is not acute. So because they combine together, it's a straight angle, so they add up to 180. So in this case, if it is in quadrant 2, the reference angle and an angle add up to 180 degrees. Of course, the angle has to be between 0 and 360. If it is more than that, then have to be something else that we need to worry about. So the reference angle is 180 subtract theta. In quadrant 3, if the angles in the standard position go like this, then once again we have to use the negative x-axis to form the angle here for the reference angle. And the whole thing is theta, taking away 180 degrees the straight angle, we have theta prime. So in quadrant 3, reference angle is equal to theta minus 180 degrees. And in quadrant 4, if we have that is theta, and we will use the positive x-axis in this case to form the reference angle. In that case, that add up to 360 degrees, one revolution. So that's what we have. So it depends on different scenarios. We go back to the definition. Just take the terminal ray and the positive and terminal ray, either positive or negative x-axis, whatever will produce an acute angle. In that case, that acute angle is the reference angle. Right. Find the reference angle of theta for each of the following theta. So if we have 250 degrees, all right, where is that? So we have 0 degree, 90 degree, 180, and 270. 250 degree would be about here. So that's 250 degree. So with that, the reference angle will be here, the terminal ray and the negative x-axis. So in that case, the whole thing is 250. Take out 180 on the top. We're left with the angle, reference angle. So in this case, theta prime equal to theta minus 180, and that 250 minus 180 equal to 70 degree. Right. Next, 130 degrees and 24 minutes. Again, 90 degrees, 0 degree, 180 degree, and 270. We don't need that far. Right, 130, so have to be between here in quadrant 2. So this is 130 and 24 minutes. So the reference angle is going to be here. We might use the terminal ray and the negative x-axis to produce an acute angle. So reference angle is 180 minus theta. Right. So I show you using the calculator on the first section already. Now if we take 180 minus 134 second angle degree and 24 minutes. If you do that, let's work. Do not put 180 degree it might still work, but yeah, so don't put a 180 degree by itself like this. Only put degree when there's a minute or second after that. So just put 180 minus that. So this is the correct answer. Of course, it cannot be negative, right? Right. Be careful with the calculator. if we just have degree, don't put the unit at all. But if you have degree and minute, then you have to put degree and minute, maybe second, but don't put the degree by itself. Right, next, negative 400. This is negative, so we have to go clockwise now. 0, negative 90, negative 180, negative 270, negative 360, and then another 90 will be negative 450. So it's going to be between negative 360 and 450, so it's going to be in the fourth quadrant. About that, I said it, fourth quadrant, that's good enough. So this one goes actually clockwise. Because it's negative. So the reference angle is going to be this. Right. By the way, there's a lot of different ways you can do this. Of course, negative 400. Negative 400. If we add 360 to it, we have the coterminal angles. So instead of use negative 400, we can use negative 40. Why? Because those two are coterminal angles. They have the same terminal ray. So in that case, essentially we can use coterminal angles to find reference angle. They will have the same reference angle. So if I don't want to use 400, negative 400, use negative 40, still works just fine. Right. By the way, if we take about 360 away, if we only talk about this part of the angle, that is negative 40 degree. Because I take away sorry. Look like the calculator has problem with the calculator. Right. So either use negative 400 or negative 40 coterminal angles will have the same reference angle because the terminal rays do not change. So negative 40 is that. So the reference angle, if it's negative 40 is that way, the value is also 40 degrees. So in this case, reference angle is 40 degrees. Because if it's negative going clockwise, it will be positive 40 going counterclockwise. Right. So sometimes we subtract 360 or add 360 to get coterminal angle, just to help us with the calculation. Just like this one, if we don't want to work with 415, perfectly fine. Subtract 360. It's 55 degree. So 55 degrees in the first quadrant. So that is also the reference angle as well. Because reference angle in the first quadrant could be the same thing, 55 degrees. So when all fails, just draw the angle out. Draw the angle, the terminal rate, either positive or negative x-axis, whichever give us an acute angle. That is the reference angle. By the way, I'm not sure if the calculator has a problem before, but the point I tried to make earlier is if you don't put 180 degree or any degree, if you use the unit degree there, it have to be with the minute and the second. You cannot just keep 180 like that. That would be wrong. Instead, if you just want 180 degrees, don't put degree at all. And this is correct. Right. I'm not sure if the calculator, if the video captured that or not, so I have to do that again. Right, next. Right, so reference angles, nice and all, but what do we need? I mean, how did that help us to find the values? And it turned out to be extremely helpful. So, let theta prime be a reference angle of a non-quadrantal angle theta. Non-quadrantal meaning it is not multiple of 90 degrees. So it's not the terminal ray does not lie on the x or the y axis, so it have to be one of the fourth quadrant. In that case, on the trig function with absolute values is equal to the trig function of the reference angle. Right? And so what's the big deal? Well, write like that is correct. However, it would be more helpful if we write like this in general. That is, when we say sine, let's say I'm using sine. Sine of an angle could be equal to plus or minus of sine of the reference angle. And here I'm saying plus or minus. I do not mean plus or minus. I mean the same sign or opposite. And the plus or minus here determined by the quadrant. So, of course, that worked for sine, but it worked for all the 6 trig function. Cosine of an angle could be the same or opposite side as the cosine of the reference angle. Will be the same thing. Right. Now with that, will be extremely helpful. With that, to find any trigonometric function values of any non-quadrantal angle theta, we need to do 2 things. First, find the reference angle and the trigonometric function values. And after that, we determine if it is positive or negative. Depends on the quadrant. Right. Let's do it. The first example, sine of 120 degrees. Sine of 120 degrees. Let's draw that real quick. $120. The reference angle is going to be here, right? We form the angles, so that is acute. So reference angle, the whole thing is 180 minus 120. It's going to be 60 degrees. So reference angle is equal to 60 degrees. And after that, we just find what is sine of 60 degrees. The reference angle, sine of 60 degrees, sine of the reference angle. By 60 degrees, we use this trick, right? We used earlier. So 0, 30, 45, 60, 90 degrees going counterclockwise. 60 degrees, that finger. Sorry, that finger. So we have the sine is square root of the number of fingers on the right. So 1, 2, 3 over 2. So square root 3 over 2. So first we find the values. Square 3 over 2. Now to find the values, we use the reference angle. Next, the sign, is that positive or negative? So sine is in quadrant 2, right? In quadrant 2, x is negative, y is positive, r is always positive, and sine is y over r, positive over positive is positive. Because of that, it is going to be positive square root 3 over 2. Yeah, I say this a few times already. I use a lot more steps than we need to, but when you get used to it, you can do all of this mentally. But those are all the things that we have to account for. So the sign is positive, and the values is square root of 3 over 2. So just square 3 over 2. That's what we have. Simple enough. Right. Now, there's a note here. I leave there for something. Right. Now remember, this hand trick can help us to find all the trig function values for 0, 30, 45, 60, and 90 degrees. Right? So if it is not of those angles, not multiple of those angles, then we have to use the calculator. There's no way. Those are the values that we know that we can find exact values easily. The others, we just use the calculator. Right. Now, the nice thing about this is, if we can, there's a quick way to find the reference angle, and it is going to be like this. So, we just try. What we do is, whatever the angle we have, big number like this, just divide by 90. If it is divisible by 90, reference angle is 90. Right. Actually, let's not try 90. Try something else. 60. So, if if the angle is divisible by 90 degrees, and that is quadrantal angle. So that is quadrantal angle. We're not talking about this. Now, the check, we start from 60 degrees. By the way, we divide by 90 first. If theta is divisible by 60 degrees. Of course, we try the first one first, and then we go to the next one. We not just go straight with 60. No, 90 first, and then if it doesn't work, go to 60. Reference angle is equal to 60. And if it doesn't work, try 45. So remember, we go check 1, 2. We cannot skip any step. Try the first one, divide by 90, divide by, if it doesn't work, divide by 60. If it doesn't work, divide by 45. If it is divisible by 45, then the reference angle is 45. And if theta is divisible by 30, then the reference angle is 30. Right, so that will be extremely helpful. Right? Now, when we have that big values, so what is the reference angle? So we start with 1, 3, 2, divide by 90 first. Nope, doesn't work. It's not a whole number. How about we divide by 60? Yes, it is divisible by 60. So in this problem, the reference angle is 60 degrees. Just like that. Don't have to draw it. By the way, it only works for the 60, 45, and 30 degrees. And that's what we can use this, right? Now 60 degree, sine of 60 degree, we already know that. Square 3/2, we just did it, right? So find the reference angle, and that using this to find the values. Now the size, is that going to be positive or negative? Yeah, so when we're trying to find the trig values, there will be, we do two things: find reference angle and the values, and then determine if it is positive or negative. So that's simple enough, right? So the sine, I will take that divide by 360 degrees, which is a revolution, and get 3.6667. So which means it will go 1, 2, 3 times around. Let's see, 1, 2, okay, 3 times around, and 667, which is about 0.667 is between 0.5 and 0.75 of a revolution. So this is in quadrant 3, right? So think about this. If we talk about revolution, 0 revolution, 0.25, 0.5, 0.75 of a revolution. Here we have the leftovers 0.667, so it's about here, 0.667 in terms of revolution. So that's why it's in quadrant 3. In quadrant 3, x is negative, y is negative. So sine is y over r, negative over positive is negative. So the answer is going to be negative and square root of 3/2. By the way, if we have a calculator, hit mode, go to degree, and after then we hit sine of 1320, and it's negative. Calculator did not give us negative square root of 3/2, but at least we know it's negative. So that helps us a lot. We know it's positive or negative. The values, the hand will take care of it. Right, so essentially that's what we do. Right, so the size, if you have a calculator, that will determine the size rather quickly. So let's just go with that. Right, next, 480 degrees, negative, doesn't matter. Does that divide by 90? Divisible by 90? Nope. How about 60? Yes, it is a whole number. It is an integer. So yes. So first, the reference angle of negative 480 degree is 60 degree. Doesn't divide by 60. Doesn't divide by 90, but it divides by 60. So reference angle is 60. Now what is cotangent of 60 degree? Well, yeah, the hand trick only works for sine, cosine, tangent. This is cotangent. But cotangent is the reciprocal of tangent, meaning that whatever we have for tangent, we're going to flip, we have cotangent. So instead of do square root of number of right fingers on the left fingers, we do it the opposite, and not the opposite, but the reciprocal. Right. So 60 degree is here, right? If we use tangent, the number of square root of the right fingers will be square root of 3 over square root of 1 if it is tangent. But this is cotangent, we have to do the reciprocal, meaning that the number of fingers on the left one, square root of that, over square root of the number of fingers on the right. So we do this in flip-flop. So that is 1 over square root of 3. That gives us the values. And then the sine. Again, we don't have cotangent. We only have 1 divided by -40. In the next section, we will do more of this. But cotangent and tangent are reciprocal of each other. So one ratio we just flipped from tangent to cotangent. Right, it is positive. If we use calculator, it is negative. I'm sorry. Positive. I'm sorry, calculate that way. So positive 1 over square root of 3. So if the calculator did not give you the exact values, we have to do that by hand. And by hand, I mean this hand. So this is positive square root of 1 over square root of 3. We can check 1 divided by square root of 3. Yeah, of course, same thing. Right, so what do we do? First, just try to divide and find what is the reference angle, and from there we just need to determine the size. I'll use calculator for that. Right, 225 degrees. What is the reference angle? 225. Does that divide by 90? That would be no. 225 divided by 60. Also no. 225 divided by 45. Yes. So the reference angle is 45 degrees. And then next, tangent of 45 degrees. Once again, the hand, 45 degrees. It's there. 2 fingers on the right, 2 fingers on the left. And the tangent is the number, square root of the number of right fingers divided by square root of the number of left finger. So square root of 2 fingers on the left, square root of 2 fingers on the right, divided by square root of 2 fingers on the left. Square root of 2 is 1. So that is 1. Next, the sine. Is that positive or negative? Of course, we can draw it out and find the quadrant and then go off that. But if we just have a calculator here, we can just do that. Tangent. It's positive. Also, if we don't have a calculator, remember in the previous section, remember the acronym own, store, take cash. Remember, we call own, store. This mnemonic A. So the first quadrant all are positive. The second quadrant sine is positive. Consequently, reciprocal of sine is cosecant, also positive. So all trig functions are positive. Sine and cosecant are positive. The third quadrant tangent is positive. This is in third quadrant, so it's positive. I can also use that. So tangent is positive, cotangent also positive, because when we flip, the sign does not change. Anyway, so this is 1. By the way, the calculator gives us 1. So it is 1. Right. Cosecant of negative 30 degrees. First of all, find the reference angle of negative 30 degrees. But that's easy. We don't even have to do all the calculation. Negative 30 degrees meaning it goes clockwise. So that's negative 30 degrees. If it goes that way, negative, counterclockwise is going to be positive, which is the reference angle. So we don't have to do anything, just reverse the sign. That's it. So 30 degrees. Now this is cosecant. How do we do cosecant? Cosecant of the reference angle. Cosecant is the reciprocal of sine. So 30 degrees. That. So 30 degrees there. 1 finger on the right, and sine is the number, square root of the number of right fingers divided by 2. That is sine. This one cosecant, so we have to flip it. So we have 2 over square root of the numbers of the fingers on the right. 1 finger on the right. 2 over square root of 1, or 2 over 1, so it is 2. And next, what is cosecant? We determine the signs. Is that positive or negative? So remember, sine and cosecant, we have the same signs, but still 1 divided by, we actually have to use negative. Sine of negative 30 degrees is negative 2, so it's negative. One divided by sine of negative 30 degrees is negative. Yeah, because we cannot type cosecant. We have to use reciprocal function. Right, cotangent of 180. So what is 180? Well, 180 is divisible by 90, which is 2. So we cannot use the hand trick. So where is 180 is going to be here, right? So we can choose any point there, and I will choose x to be negative 1, y 0, and then r is equal to 1. You can choose any values. Could be negative 5, any negative number will do. Y equal to 0 because it is on the x-axis, and r is the distance from that point to 0, so obviously it's going to be 1. And then cotangent, what is definition of cotangent? X over y. Because that's undefined. Yeah. So whenever we have quadratic angle, to find the trig values, what we do, we use x, y, and r, meaning use definition. Using x, y, and r. So when we have quadratic angle, don't try to do any reference angle or anything. just draw it out and find out x, y, and r, and use definition to find those values. If it is not quadratic angle, try this first. Try 60. If it works, reference angle is 60. If it doesn't, go to 45. If it works, reference angle is 45. If it doesn't work, go to 30. And if 30 doesn't work, you cannot use this. Use a calculator and find the approximation. Right, next, 315 degrees. Right, 315, and by now we know that if it ends by 5, it will divide by 45. If it doesn't, calculator can get the approximate values. Because if it 315, it cannot divide by 90 for sure, or 60 for sure, because it has to end with 0. If it ends with 5, try 45. If it works, great. If it doesn't work, the calculator will take care of it. I will talk about that at the end. Right, so reference angle here is 45 degrees. Now, secant of 45 degree is 1 over cosine of 45 degree. Alright. So cosine of 45 degree cosine is the number square root of the number of left fingers divided by 2. But this is secant, so we have to flip. So it will be 2 divided by square root of the number of fingers on the left, which is 2. So 2 over square root of 2. Yeah, of course we can simplify that. Remember, rationalize the denominator, multiply square root of 2 on the top, square root of 2 at the bottom. Why we do that? Just so we have 2 at the bottom. Square of 2 times square root of 2. And then 2 and 2 cancel out, we have square root of 2. So that's the values, square root of 2. How about the sine? Well, is that positive or negative? So we still cannot type cosecant of 315. So secant of 315 degree is 1 over cosine of 315 degree. So use the reciprocal. And if we say 1 divided by cosine of 315, it is positive. So the answer is positive square root of 2. Of course, square root of 2. Right, so that's good and all, but what if, like I said, if we have the multiple 60, 45, and 30, we can get the exact values. If we have to do like sine of 115 degrees, and that does not divide by 60, does not divide by 30 or 45, in that case, we just get the calculator and get the approximation. So this is approximately equal to something like that. So that's all we can do. But if it is a multiple of 90, that quadrantal angle, we use definition with x, y, and r. If it is the multiple of 60, reference angle is 60, trying to find the trig values first, and then use either the quadrant, or we use this trig, or we use a calculator to determine the sine. We have the values from reference angle and the sines together give us the values of that trigonometric function. Like I said, you don't have to do all of this step, but when you get used to it, we will do that quickly. I will write out all the steps because all of this we have to think about even if we do it mentally. Right, once again, find the reference angle and the trig values for that reference angle, and then determine the sine. The sine together with the values is what the trig value function is. Right, so that's why the reference angle is very important. That helps us to find something that's a lot more complicated. Just break down any angle into an acute angle. Right, I stop the section here. As always, thank you for watching.